This conference will now be recorded.
So GBIM will be very important aspect because what takes 1 hour to do coding with a proper GBIM skill, you can finish that coding in 15 minutes, right? So that way, learning GBIM effective will be very important for you, and it all comes with the practice, right? There is nothing like automatically your things won't happen. You'll have to spend time and practice it. And I want you to take the next 6 months very seriously. I mean, to treat it as a very important phase of your life, not just your education. Overall life, it should be a very important part of your life where you don't deviate much into your personal things or non-technical aspects like going around. It should all be cut down. Your focus should be only on learning the things. This is going to define your career. This 6 months is going to define your career because if you VLSI is one domain which is different from software. How is it different? In software, every 3-4 years they have to keep upgrading themselves. 5 years back there was big data Hadoop. Now they are talking about something else. Another 5 years later, some other new software they need to learn. That keeps happening, right? Probably sometime Java was there, then .NET, then uh, big data, then artificial intelligence. A lot of new things are keeps happening, and they need to do a lot of things to keep themselves keep upgrading. VLSI is not such thing, not like in 2000, back in 2005 when I started my career, I learned system Verilog sometime around 2006 or so. The same knowledge, same skill set is even applicable today also. Some protocols I learned during 2008, 2009, AXI, AHP, they are very much applicable now with some little updates. So whatever effort I would have put during that time, 1 year, very, very effective effort, my other time will be very relaxed. In software, it's not like that. It requires a continuous upgradation. So I want you to treat this 6 months as very serious effort and give your best. Okay, and it will make your career very easy actually. Right. So now let's get into the syllabus. So by now, you see you have completed digital and you have completed GBIM. Okay, so irrespective, I won't go into the time, how much time we spent. Idea was to go deep and understand deep. In sequential, we have left some topic that will be covered during the Verilog training because we didn't want everything to be taught to PD students and DFT students because for them it's not really relevant. For a front-end engineer, that is design verification and functional verification engineer, those advanced topics will be relevant. So we will include them as part of the Verilog course. Now, what is the plan going forward? Verilog will be done over next 1.5 to 2 months. I mean, 1 month will be for language training. Projects will go for around 3 weeks. This would be the plan. Ideally, we'll plan this for 3 weeks itself. But if it stretches beyond 3 weeks, maximum 6 to 7 weeks, everything should be completed. Once it is done, we will be starting with, I mean, there might be a 3-4 days break. Okay. Then we'll start with system Verilog language. That will go for 7 weeks, 6 to 7 weeks. Then we'll start with UVM. That will go for 4 weeks. So what do I want to tell here is 6 plus 7, 13, 13 plus 4, 17. That is 4 months. Roughly 17 weeks is how much? Months. By 4 months, your Verilog SV UVM preparation will be done. What will be left will be the projects. See, initially during this itself you will be doing, I mean, Verilog itself you will be doing projects, but some advanced projects will be doing after this. Sorry. So the projects, we'll be doing projects like AXI, even during this itself. Sorry. We'll be doing some AHB project. Then AXI project will be done separately. One main project will be done, the net Mac. So we'll keep the projects towards the end of the course because mostly the hiring happens based on these things. When you go for interview, these are the things which decide the hiring. And after that, once you have gained expertise on Verilog system, Verilog UVM, we'll focus on the projects. Then of course, during these times, scripting will happen, Linux will happen, all those things will be covered. Let us get into Verilog. So as I said, the plan is for to learn over next 3 to 4 weeks.
And in which
Have
tool
you
we
done
will
anything
work,
on
sir?
Verilog yesterday? Sorry,
In which tool we will
which
work,
tool
sir?
you are telling?
Yeah. Yeah.
Okay, fine. See, Verilog will be done using model sim tool. Okay. SV onwards, system Verilog onwards will be using sim tool. UVM also sim. Projects also using sim. Okay. So, have you installed model sim tool? No. Okay. The trainer will help you with the installation tomorrow. So after that, we will have a lab session from tomorrow onwards. Okay. So today it will be completely focused on my session only. It will be like a theory session where I will be teaching everything. Okay. So there won't be any lab session for today. So let us start with the Verilog language. Like for a software engineer, C language is the foundation, right? Similarly, for a front-end engineer, that is functional verification engineer, design engineer, anyone who is working into VLSI front-end domain, not the back-end domain. Anyone who is working into VLSI front-end domain, Verilog is a foundation course. I mean, if you are good with Verilog, very good with Verilog, system Verilog is very easy actually. Then UVM also becomes easy. So this will be a foundation course. We'll try to make it as simple as possible for you to learn. Okay, again, we'll divide it into 2 aspects. 1 week of training on combinational logic. Then remaining 2 to 3 weeks on sequential logic and other aspects, advanced aspects. So now let us start with the session. So you can find this presentation on the e-learning portal. You might have got access to Verilog e-learning course. So I won't go deep into it. I mean, let me tell you, we'll cover everything in Verilog. Someone asked me, I'm attending Verilog course, which book I need to follow? I would say no need to follow any book because I will probably say what we cover in Verilog will be more depth than Bhaskar book. The other authors, right? Some Verilog books will be there. You don't need to really refer to them. Mostly our presentation will be good enough and your learning should be like that only. You should not be looking at too many resources. Looking at, I attended the lectures, how much knowledge I can get out of it. If I'm stuck with some doubt, how can I talk to the trainer and get my doubts clarified? If you try to refer to 2-3 books, you will not have so much time. By now you would have realized that things move very quickly. So digital happened, you started digital and by the time you realized it is over. Digital started, it is over. Right now GVM session won't happen again unless you request for one. Same thing with Verilog. So you will not really have so much time to refer to another books. I think maybe week or so will give you the hard copies. I think we are getting in the process of getting all these things printed. So we'll give you the books that will make it easy for you to refer to the materials. Okay. So my suggestion is, unless if you are not able to follow, talk to the trainer, whatever wherever you are stuck, you get the support. Do not go for other material as of now. Okay. Now, so let's start with the basics. I think working with GVM editor, you are all clear. Now let us start off with understanding how the Verilog language has evolved. I mean, what is the need for a Verilog language? If you see, electronics have evolved during 1960s. I mean, if you go back to 1800s, was there any electronics concept? There was no concept of transistors. There was no concept of probably power itself was not there. Current was probably invented, right? Bulb was invented. And after that, electronics came in. That is where the transistor got invented. Back in 60s or 50s or 60s, the designs were simpler. So those designs can be implemented using few transistors. I mean, that is where you come across the terms SSI, MSI, LSI, VLSI. Then you had one term called as UVSI. What is that? Ultra VLSI, right? You know the transistor, right? Roughly. All that you see is as you go from SSI to number of transistors keeps increasing. Designs with fewer transistors can be manually modeled. What do you mean by that? Let's say if I take a design with 5 transistors, what is MOSFET transistor has typically? Gate, drain, and source and substrate or base. These are the things you have. If you have 5 transistors, you need to connect gate and drain of one transistors. I mean, you need to do the connections to come up with an effective circuit. If it is 5 transistors, 10 transistors, it can be
Sir,
done
your
manually.
voice is
There is no
again
problem.
some in between.
Okay. How about others? Others are also facing issue. Yeah, others is facing the issue. Okay.
No,
Okay.
sir.
So maybe problem in my
See, model.
No, sir.
Okay. Yeah, model sim. One second. Those who are facing the issue, if it is only 1 or 2 people facing the issue, you get the recorded video. You please go through that video. If everyone is facing, let's say there are 40 people, everyone is facing the problem, then it's my internet issue. If 90% is good, 10% is not good, then you need to look. You can log off from the session and log in again. Okay, it might solve the problem. Okay. So I was telling you that when you have design with fewer transistors, you can do manually modeling. However, as the transistor count increases, increasing, imagine 100 transistors. How to connect to which drain to which gate, which transistor to connect which transistor. That all becomes difficult. Now, in the current day, today, what is the complexity of design? How many transistors do we have in a chip? Billions. Means 100, at least 100 crore transistors in this mobile phone. Okay, that cannot be done manually. So it becomes difficult to model design manually. Current complex designs like mobile SoC, server SoC requires billions of transistors, which can't be modeled manually. So if you can't do this manually, what is that you go for? Automation. You go for automation. So we need to automate this process. So that is where we have a solution. Implement the design behavior in a high level description. Instead of working at transistor level. I mean, let's say I want to develop a mobile phone chip, mobile phone. That is my intention. Okay. There are 2 approaches I can do. I mean, manually come up with 100 crore transistors. Start connecting them manually. What do you mean by manually? This transistor 1 gate will connect to this one, transistor 1 drain will connect to this, transistor 1 source will connect to another transistor, like that manually. Do you think is it possible? Not possible, right? 100 crore means lifetime to take, right? So hence this option, this is ruled out. This is not possible. If it is not possible, what is the solution we have to? If you can't do manually, what is that we have to approach? Automation, right? That is where they needed an approach. On top of the screen. Okay. That is where they came up with a solution where implement the design using high level description language and convert this description into gate level. do not implement design directly using transistors. So the answer is what? Don't directly start with transistors. Rather start with a high level language. I mean, more like a writing like English, what you want chip to do. That is where Verilog and VHDL came into picture. Then use EDA tools to convert this description into transistor level. So what does EDA tool stands for? EDA stands for Electronic Design Automation. Means you're automating the process of electronic designing. So that's why those tools are called as what? Electronic Design Automation tools. Let me tell you one thing. If EDA tools are not there, what is an example of EDA tool? Design compiler. Even model sim is an example. The model sim I'm talking, Questa sim, the prime time, star RC, everything is an example of a even Cadence Virtuoso. Anything that you hear in the VLSI terminology is a EDA tool, right? If these tools were not there, then we wouldn't have at least 95% of the electronic we are using today. This laptop is not possible, mobile phone is not possible. None of these complex designs were possible if EDA tools were not there. Okay, what does it mean? If by any chance Cadence, Synopsys, and Mentor shuts down today, any future products are down. Because all the strength, whatever we are doing, it's all because of the power of automation. We are able to automate the complex parts using those tools. So next comes, what is my high level description? See, I'm using the term high level description. What is meaning of this high level description? Let us understand the term. What we mean by high level description. Then if there is a high level description, there must be low level description also, right? If we high level description, then there is a low level also. To understand what is high level description, to understand what is low level description, let us take one example. I will take the example from your digital design course. Have you studied basics of counters? Have you studied basic counters in digital design? Right? So let's take a counter. Counter have you studied? Synchronous counter. Let's say you say have you studied mod 6 counter? Let's take an example of mod 6 counter. Now, using this mod counter, you have during the digital design, what you have done, you only studied the design aspects. I mean, how to come up with the design for mod 6 counter. Now, what I will do is, we will go into the Verilog implementation of the mod 6 counter. Now, what I want to do is, we want to fabricate a chip which behaves like mod 6 counter. We want to fabricate a chip which behaves like a mod 6 counter. Now, if I use high level description, mod 6 counter high level. This is that I'm doing mod 6 counter high level. .v means what? It's a Verilog file. If I do it here, module mod 6 counter. Name of the module is what? Mod 6 counter. A counter typically will require clock and reset. Counter, is it combinational logic or sequential logic? What is one unique thing that sequential logic will definitely have? Clock, and reset will be there. Whenever clock is there, reset will be required, because if you want to bring it back to normal state, you have to reset it. Any sequential design you take, clock and reset will be compulsory inputs. Tell me, are they inputs or are they outputs? Inputs, right? For my design, things will be input. What is the output of a counter? Count. Count is the output, right? No. The input or output? Inputs, right? Clock, reset. count, is it input or output? Output. For a mod 6, what should be the size of count? 3 bits, right? To represent 6 unit, 3 bits. How do you write it? Output 2 down to 0. Anything that is 3 bit, you have to write 2 down to 0. What if it is 5 bit? 4 down to 0. This is called as vector. In terminology, this is called as scalar. 1 bit variables are called as what? Scalars. Multi-bit variables are called as what? Vectors. So remember this terminology throughout your lifetime. Vector means what? Not the physics vector. Okay. Vector means what? Multi-bit variable is called as vector. Scalar is what? Single bit variable. So that will be used throughout our course. Okay. Next. In a high level description, we write it like a English. We develop the design more like a English. What is the mod 6 counter? Tell me. Let's come up with the algorithm. Right? You can think of in Telugu, Hindi, Kannada, whatever language. Let's write for our convenience. Let's write it in English. I'm going to write algorithm. What is the algorithm of a mod 6 counter? At every positive edge of clock. At every positive edge of the clock. What will happen if reset is applied? Count will become. Tell me, if I reset the counter, what will happen to the count?
It comes to 0.
If reset, it will become 0. Else, it keeps incrementing, and whenever it reaches 5, it becomes. Then it will go to. It will go to 0. Did you understood this algorithm? Okay. Everyone, please read it. If you didn't understood, please tell me. Please do not write notes. Someone might be writing notes in online also. Don't write these notes. Everything will be shared with you. Please focus in the session. And whenever you are stuck, wherever you are lost, you can feel free to stop me, right? Generally 3-4 hours session will be very long, right? You can lose some focus. You can start thinking many other things. When you come back, when you are not able to follow, please stop me and ask me where we are. You read this, right? Now, Verilog coding is all about converting this algorithm into Verilog language. The coding is all about converting English or whatever language you wrote algorithm into Verilog format. You have written in English. That algorithm line number 5 is what? English. That need to be converted to Verilog. How do I convert to Verilog? At every positive edge of the clock. How do I write that in Verilog? How do I write at every positive edge of clock? How do I tell that in Verilog? That is told as always at the rate of positive edge of clock. Always at the rate, you know, right? Symbol itself means what? At the rate of positive edge of clock. That means always at every positive edge of the clock. Begin end, because you are starting some coding and it has to be put between begin end, and that you must have learned from many languages, right? Everything has to be between either flower brackets or between begin end. In Verilog, we don't use flower bracket. What do we use? Begin end. In C program, what do we use? Flower bracket. That's all. Wherever instead of flower brackets, you imagine it. Next. What are we telling if reset is applied? How do you check if reset is applied? If RST equal to 1. Begin, end. What should you do? Count equal to. Simple, right? If reset is applied, make count equal to what? 0. Else, what should you do? If not, if reset is not applied, what should you do?
Count equal to count plus 1. Count plus 1.
Count plus 1. See, I'm using GVim. What I'm using is GVim techniques to make my coding easier. Then what should I do? What does my algorithm tell? If count reaches how much? Actually, once it crosses, if it reaches 6, make it 0. That will be right. It should, mod 6 means what? 0, 1, 2, 3, 5. Then again 0. So 6 should not happen. So what I'm doing is, if count becomes 6, make count equal to what? 0. That's, this completes our Verilog coding of counter. This completes our Verilog coding of counter. Is that clear to you? Right? This is called as high level description. The same thing I can do using low level also. Let us spend 5 minutes, come up with a low level description also. And whatever I'm going to do would be very familiar to you because you have already done it during digital design. So what I'm going to do now is low level description of counter. So what is meant by low level? What is meant by low level description of counter? It means that think of everything in terms of gates. Come up with design in terms of gates directly. Don't think of if condition, don't think of always condition. Directly come up in terms of gates. If I have to come up with some circuit in gates, how do I start? See, before it became gates, what was it? Right. Before it became Boolean expression, what was it? How do you get Boolean expression? From where do you get K-maps?
From truth table.
Before it became K-maps, then what it was? Before it became truth table, what it was? The design behavior. The design behavior is written into truth table. The truth table is put into K-maps. K-maps is then converted into Boolean expression. From Boolean expression, you get the gates, then implement the gates. So where should I start? Should I start with the gates or should I start with the design behavior? Design behavior. Do we know the design behavior? We know, right? Count will keep incrementing. I know what is the current count and I know what is the next count. If I know that, can I write the truth table? Can I write the truth table? So let us write the truth table. Current C2, C1, C0, N2, N1, N0. Clear? 0, 0, 0. What is the next count? 0, 0. Clear till this point? 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. Will this be there? No, right? At 1, 0, 1, it will stop. What this will be? Do you agree that this is a mod 6 counter truth table? Is everyone clear? Those attending online, are you clear with this? This is the mod 6 counter truth table. Now, once you have truth table, what do? We have to decide. Before we go to K-maps, we have to decide, is it a combinational logic or sequential logic? It is sequential logic, right? I mean, for me, counter is a sequential logic. So what will be the basic building block of sequential logic? Flip-flops. Flip-flop is the basic building logic. So I cannot directly start writing N2, N1, N0. What do I have to do? I have to decide what flip-flop I'm going to use. what flip-flop I'm going to use. Am I going to use D flip-flop, JK flip-flop, SR flip-flop, or toggle flip-flop? How many types of flip-flops are there? 4 types. Now I have to decide which flip-flop do I have to use. Okay. And one more thing I just want to tell you, this complexity will be there only for next 15 minutes. After that, I'll be moving back to multiplexer, basic, and get or get only. I'm just trying to teach you why Verilog is required. Once it is done, we'll move back to very basics of Verilog. Okay. So what do we do here? We need to decide flip-flop. So let us say we'll go with the simplest flip-flop, that is D flip-flop. So then I have to do what? D2, D1. How many flip-flops will be required? 3 flip-flops will be required, because at any point in time, how many states need to be remembered? How many values need to be remembered? 3 values to be remembered. Count is 3-bit. So how many values need to be remembered? 3 values. So how many flip-flops are required? 3 flip-flops. If you need 3 flip-flops, how many D inputs are required? 3 D inputs, D2, D1, D0. Now going by the concept of flip-flop behavior, what should be the D2, D1, D0 value? What should be the D2, D1, D0 value? It should be same as current count or next count. It should be the same as next count. You know, right? You haven't studied this in sequential. The input should be same as what? This is what I want my flip-flop output to be. This is what I want my flip-flop output to be. Then what should be the input? Input should be same as the output, right? What is for a D flip-flop? What is the excitation table? Whatever is the input, same will be the output. If I want my next state to be 0, my D2 should also be 0. If my D1 N1 has to be 0, D1 has to be 0. If N0 has to be 1, N0 is the next state output of the flip-flop. N2, N1, N0 are the outputs of the 3 flip-flops. If 001 has to be the output, my input also has to be 001. Do you agree with that? Next. What is the states here? 010. Actually speaking, you will realize that you don't need to write it, because rather implement the K-map directly for this. But I'm trying to tell you that this is the approach you have to follow. Here you write 011, 100, 101, then 000. Flip-flop. Then what I would have used? J2, J0, K0. Then what I have to refer to? I have to refer to excitation table. On that I have to get what should be the J2, K2 values, so that this transition happen. 0 to 0 transition will happen. 0 to 1 transition happen. Accordingly, I have to come up with J2, K2, all those values. Right now, to keep the thing simple, which flip-flop are we using? D flip-flop we are using. Now, I need to come up with the K-maps for what variables? Tell me. D2, D1, D0. Basically, they will tell me what should be the values of D2, D1, D0, so that N2, N1, N0 will keep toggling in this manner. Now, what I will do, I will write the K-maps for. Now we write the K-maps for.
10,000 rupees on Google Pay for business.
Okay, so let us draw the K-maps. How many entries will be there in the K-maps? How many boxes will be there in the K-maps? Please tell me. Have you seen any K-map? Have you seen any K-map with 7 boxes? Have you seen any K-map with 6 boxes? So what should be the K-map use? 3 variables, right? So I should use 8 boxes will be there. So I will go with 4 cross 2, 4 rows, or sorry, 2 rows, 4 columns. So let us draw one such K-map. what came up, right, for 3 variables. What are these two? This variable names will be not. So this right now. So what are these values? 1, 1, 1. You're all clear with these things? 0. Clear the point clear right now. Tell me for what all things D2 is true. 3 and 4, right? Right. 3 and 4. 0, 1, 1 and 1, 0. 0, 1 is, let's take a different color. 0, 1, 1. 0, 1, 1 is what? And what is the next one? 1, 0, 0. 1, 0, 0 is X means what here? Now can I group them? Can I group them? How many groupings have to do? 2 groupings have to do. I cannot go, can I group all 4? Not possible, right? It will become a non-rectangular shape or non-square shape. So what is the C2 C0 bar? C2 C0 bar. So D2 is C2 C0 bar or condition. What is the bottom one? C1 C0. C1 C0. Clear? Now let us write for D1 also. Let's write for D1. D1, where is it true? 1 and 2. For 1 and 2 it is true. What is 1, 0, 0, 1? Let's take a different color. Let's write for D1. 0, 0, 1 and 0, 1, 0. And of course this is there anyway. Can you tell me what grouping can I do? Top I can do grouping of 2 boxes. Bottom can I do grouping? I can't do grouping, but I have to take single only. Now can you tell me the top Boolean expression? C1 C0 bar. What is the bottom one? C2 bar, C1 bar, C0. Right. Let's write for D0 also. Where is D0 true? 0, 0, 0. Basically 0, 2 and 4. 0, 2 and 4. What is 0? Let's different color, green color. 1, 2 and 4. Here it is. Can I group? What is it? C0 bar. Clear? Okay. Now with this, I can develop a Verilog code. Mod 6 counter. Low level. Mod 6 counter, low level. You know what? Only one thing is it should be reg actually. Let me not confuse you with reg and wire. Just understand that this should be a reg. Always block. Anything that you always block should be use it in reg. Now I'll take the same code here. I'll remove this part because I'm not going through the algorithm part. I'm developing in a different manner. If I develop in low level, my codes won't change. Whatever you do, whether you go with high level approach, whether you go with low level approach, clock and reset will be the inputs, count will be the output, right? And clock and this will be still same. So this part of the code will be same for both high level description as well as low level description. So what is the changes is now we won't be doing algorithm, like we won't be developing like a algorithm always at the rate positive edge of this happens to this. No, that is called as high level. What is low level is just take these 3 lines, paste it. Just take 3 lines, paste it. To do something called as assign. We'll use Verilog concept. Assign. D2. Okay, capital I'll use. Instead of C2, see count is vector, right? So for C2, I'm going to write count of 2. The count variable second bit. ANDed with what? Inverse of count of 0. ORed with count of 1. ANDed with count of 0. I just converted C2 to count of 2, C1 to count of 1, C0 to count of 0. Now the same line here, it becomes assign. C1 becomes what? Count 1, ANDed with count of 0. ANDed with, because it's AND related to, right? Count of 1. Again ANDed with what? Count of 0. And ending with semicolon. Here what does it become? Assign inverse of count of 0. Right. This is one level of Verilog coding. Okay. Next, I have to use something called as I'm showing you the complex part. I told you one statement sometime back, but this complexity will stop in another 5 10. After that, we'll move to very basic of Verilog. Very basic of it's Verilog. I just wanted to show you why Verilog is important. Okay, why we are moving from direct digital design to Verilog. Okay. Next, we again have to develop something called as module D flip-flop, because we are using D flip-flop, so we need D flip-flop, clock, reset, D, Q. What is the D flip-flop behavior? Input, clock, reset, D. For a D flip-flop, clock and D are the inputs. What is it? Q. Always at the rate of positive edge of clock. At any positive edge of clock, if reset is applied, Q will become 0. Else Q will become D. This is the behavior of a D flip-flop. What is the behavior of D flip-flop? At every positive edge of clock, if reset is applied, that is reset equal to 1, make Q equal to what? 0. Else make Q equal to what? D. Whatever is the value of D. Now I have to use the D flip-flop also. D flip-flop, because how many D flip-flops need to be used? 3. So D flip-flop 0, inst 0, U0. I'll call it as U0. The clock is connected to clock, reset is connected to reset. D2 is connected to D input. Output will be count of 2. U2, U1, U0. Become D1, 0, count 1, count 0. This completes my Verilog of D flip of mod 6 count. Okay, now what I will do is it's time we'll develop a test bench and I will show you the simulation. With that, we will stop this topic and we'll go to the next topic. So what I have done right now is I have taken a mod 6 counter. I have implemented it using behavioral style. How much time did it take to code this? It took me only 2 minutes. To develop a code like this, always at positive edge of clock, if reset equal to 1, make count equal to 0, else equal to count plus 1. If count becomes 6, make count equal to what? 0. It took me how much time? 2 minutes. How much time did it take me to do this low level description? At least it took me 15 minutes or half an hour time. This is what we are trying to understand. See, what we are trying to prove is, because in Verilog, you can directly start with a high level. Like what is meant high level? You write like English, always at positive edge of clock. If reset is applied, make count equal to 0. If it is not applied, increment the count. Whenever count becomes 6, count equal to 0. Is it looking like that here? So do you see anything like count becoming 6 and it count becoming 6, count becoming 0? No, right? This is called as low level description. This is called as low level description. This is called as high level description. Clear, right? Now we want to prove that this low level and high level descriptions are both are same. They should work, right? So it's not like you did low level and it stopped working. Will it make any sense? Or you went to high level description and it didn't work. Does it make sense? No, right? Both should still work. Then we should figure out which one is better for. Okay. That's what we are trying to prove. So to prove that, we need to do something called as Testbench. Testbench counter. I'm going to develop something called as Testbench. The intention of Testbench is to apply inputs to the design. It applies inputs to the design, and based on the output, we'll check whether it is working properly or not. So since I'm going to use the counter, I have to include mod6 counter high level dot v. First we'll run with high level. After that we'll run with what? Low level. Module tb. tb stands for what here? Testbench. tb stands for Testbench. So going forward, you'll understand that we'll have to do something like rich. In some connections we have to do. If some of you are not able to really follow this, for now, please ignore. I mean, I don't want to explain everything like what is and why. Another half an hour or so, I'll be explaining all the things, because when we start with multiplexer, single full adder, half adder, it will be much more easy for you to understand. Next, I have to instantiate this design. DUT. Next, initial, begin, end, clock equal to 0, forever #5, clock equal to inverse. This is called as clock generation. For a sequential design, clock is required. I am generating the clock. I am generating the clock. What is meant by forever #5 clock equal to inverse of clock? Means for some time it will be low. For 5 units it will be low. 5 units it will be high. Again for 5 units it will be low. 5 units it will be high. Tell me the time period if that is the case. 5 units is low. 5 units is high. So what is the time period? 10, right? Low time plus high time. So the time period is 10 nanoseconds. Next, I have to do something called as another 4 minutes we are done with this. Okay. Reset equal to 1. We have to apply reset. Hold reset for some time, because once you press, you have to hold the reset, right? Then you release the reset. This is called as releasing reset. This is called as applying reset. This is called as holding reset. You're holding the reset, right? Only then it applies. Let's say if right now in my laptop my finger is on the reset. Is reset happening? No. I have to press the reset and hold it for some time. Sometimes 20 units. It could have been 10 units also. For that matter. Then you run the simulation for some 500 units. Like run things for 500 units. Then end the simulation. Finally, what do? You end the simulation. So this is called as Testbench. Now what I'm going to do with this understanding, let's run the simulation and I'll show you how the things come up. So for now, you don't have to go through this process. Actually, my laptop has changed. I mean, my other laptop is give for work. So hence I'm another laptop. Hence I'm connecting to server and doing everything. So I'm just copying from my server into my laptop into the server, because my files are in laptop. Server is some other system, right? I'm just copying. Similarly, let's develop low level also. I copied the low level code also. Now what I have to copy? The test bench I have to copy. Test bench counter. Copied everything. Pasted. Now I'm running simulation for what? High level or low level? High level, right? So what I'm going to do is I'm going to invoke my QuestaSim tool, home tools, mentor, syslabus mentor, vsim, vlog, tb content. So the compilation is done. How many errors are coming? 0. And how many warnings? 0. Means compilation is done. The next thing I have to do is called as elaboration. Now what I'm doing is called as elaboration. Elaboration is done using the command of vsim. Vsim tb. What you want to elaborate? That my topmost module name is tb. In my environment, topmost module name is tb. So I'm elaborating it. Elaboration is done. Wow, there is a problem. I have to do hyphen. No, we have to 1 second. I am not speaking anything. I'm just running the simulation right now. If you see this behavior, if you notice this, how is it running? Initially, what was the count value? 0. After that, it became what? 1. After that, 2, 3, 4, 5, and again 0, 1, 2, 3. Is it behaving like a mod 6? Like a mod 6 counter? And do you see clock is running continuously at every positive edge of the clock? Can you see here? At every positive edge of the clock, count is going from 3 to 4. The count is incrementing edge of the clock. And when reset is applied, what is the count value? 0. After once count reset is made 0. Now what I'm going to do is, whatever steps we have done, right. Give me a few minutes, I'll check and update you. Okay. Instead of high level, what is the time running? Low level. The mod 6 counter, low level. That is the one which is implemented using the flip-flops and logic gates. One which is implemented using flip-flops and logic gates. Let us run that now. Those attending online, just give me a few minutes. We'll check the connection. Okay. In the meantime, if you see here, I have run the simulation with what? Low level description. What do you mean by low level description? Using logic gates, and do you see the count behaving in the same manner? 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Can you see? So the point is whether we use low level description whether we use low level description or whether we use high level description, we are still getting the same behavior where the count is going from 0, 1, 2, 3, 4, 5. Again, it is becoming 0, 1, 2, 3, 4, 5. The count is implementing in the same manner. Which one is easier? Which one is easier? High level description is much easier. So design can be implemented in two ways. Any design can be implemented in two ways. One is using high level description, is low level description. Which one do we prefer? High level description is more similar to, more like writing English or any language of our own. Okay. Low level description is what? It's a complex process which involves logic gates. I mean, which involves starting with the truth table, then going to K-maps, then Boolean expression, then the flip-flops and gates. This is a very long process, but you see, both are same. Which one should we prefer? High level. So that means 100% of the times. 100% of time means what? Always. We will prefer high level description only. Then the question comes, why then low level description is required? That is the case. Why do we require low level description? Tell me. If high level description is easy to do, why do we need to understand low level description?
So when we want to customize the things, then I think low level.
Not like that. See, when we go to purchase a mobile phone, he will not sell you the Verilog code. He won't sell you always at the rate of passage of clock, and he won't ask you to use it as a mobile phone. Can he give you Verilog code and ask you to use a mobile phone? No, right? Finally, this high level description gets converted into low level, and that low level description is what actually gets manufactured into the mobile phone. So high level description to finally gets manufactured. When in between it goes through gate level, it has to be converted into low level description. Then finally chip gets manufactured. So it has to convert. This is where EDA tools come into picture. This is where EDA tools are important. Always what do? We implement design using high level description. You use EDA tools. In this case, this conversion of high level description to low level description is called as synthesis. It is called as what? Synthesis. So using synthesis tool, there is a tool called as design compiler, or there is a tool called as genus. Tool called as design compiler or genus. Using these two tools, we convert high level description into low level description. Low level description means what? Something which is in terms of logic gates, AND gate, OR gate, multiplexer. Once you have that level, you can manufacture it. See, you can't manufacture always code. Can we manufacture always like by typing always in a chip? No, right? Can we type if condition? No. Fine. It has to be converted into low level. That is why low level description is important. But from a coding perspective, do we worry about low level description? No. We only worry about what? How can you code at high level? How can we implement the things at high level? Because why high level is very easy to do? It's more like English. See, what is it like? At every positive edge of clock, if reset is applied, make count equal to what? 0. So you write that logic. If reset is not applied, increment count. Then if count becomes 6, make it 0. Does low level description look so simple? No, right? You have to worry about writing assign statements, implementing D flip flop, everything. Okay. Hence, we don't prefer this. same approach is followed even when you code very complex designs also. Let's say mobile phone. We never with Boolean expression, we never go with truth table and other things. We directly start with what should be the behavior of a mobile phone. You write it like English. If reset is applied, mobile phone should switch on. If this is done, mobile phone data transfer should happen. Like that, you write down algorithm. That algorithm is converted into high level description. What is meant by high level description? Writing like always at passage, do this, then do this. More like English. There are tools called as synthesis tools. What are the tools? Synthesis tools. If we give this code as input to the synthesis tool, what is the code? High level description code as input to the synthesis tool. It will automatically convert it into low level description. Automatically it does. Instead of whatever work I did, what all works I did, I wrote down truth table. Then I did K-map. Then I came up with Boolean expression. All that work, who will do? Synthesis tool will do. So what is better for me? Should I directly start coding low level, or should I start with high level? High level, and give the rest of the work to whom? That is what we do.
Sir, there is a
So
question.
with this, we will stop. Yeah.
Sir, there are n number
Yeah,
of
please
ways
tell me.
we can make this counter. There are n number of ways by using a D flip flop, JK, or maybe some other logics can be applied.
Yeah.
So how the synthesis tool will work?
Yeah.
I mean, how they optimize the things and choose the best way.
Synthesis tools have some algorithms like there is something called as library where you tell what is your target flip. If you want to target it to generate D flip flop, it can target D flip flop. Right? In all that, it will still optimize. See, if you take D flip flop and T flip flop, it does the measurement. D flip flop, I mean, if I use D flip flop, this many gates are required. If I go with T flip flop, let's say it requires more flip flops, more gates. What does it decide? It goes with D flip flop. Basically, synthesis tool works in such a way that it will figure out if I do 2-3 styles of synthesis, which one gives me the lowest number of gates. It is what it will do. Any questions?
Okay, sir. Fine. Thank you.
Okay, sure. Let us do one thing. We will take a break for 10 minutes. Okay. In the meantime, I'll check my internet connection, what is happening. And we will meet in 10 minutes and we'll continue with the session. So the break for 10 minutes now. No, we are not going to do synthesis or anything. I'm just introducing you to the concept of synthesis. Okay, that's all. So let us resume the session. So we were discussing low level description, high level description. So where did we start all our discussion with? We started with discussion with what is the need for Verilog. Okay, that is where we took an example of a counter, mod 6 counter. We understood two approaches. Mod 6 counter can be implemented using high level description, low level description. The high level description is generally called as behavioral level of description. High level description is called as what? Behavioral level of description. So there are Verilog has 4 levels of coding, 4 styles of coding. 4 styles of coding. One is called as behavioral style. One is called as data flow style. One is called as structural style. One is called as switch level style. Behavioral style is the most preferred one, actually speaking. Generally what happens, logic can be 2 types: combinational logic, sequential logic. Preferred for combinational logic. If you want to implement a combinational logic, you prefer data flow style. If you want to implement sequential logic, you prefer behavioral. Behavioral means using always block. Data flow means using assign statement. So whenever I use assign statement, see here, I use assign statements. So this is an example of a data flow style of modeling. Data flow style of modeling. Here I use what? Always at the rate of positive edge of clock. What is this style? It is behavioral style of coding. It is behavioral style of coding. And combination logic is what? Whenever I use assign statement, it is called as data flow style of coding. Then what is structural style is using gates, using logic gates. All this is called as
Received 15,000 rupees on Google Pay for business.
So whenever I use logic gates, whenever I use other blocks, other smaller modules to implement bigger modules, these are all called as structural style. We will be talking about all these things. Then the fourth one is what? Switch level using NMOS, PMOS switches. If I implement things using NMOS, PMOS transistors or switches, it's called as switch level. These nobody uses this. Switch level nobody does, and even we won't be studying during our training. Now, what is the design that we took before the break? Mod 6 counter. Mod 6 counter is sequential logic or combinational logic? So which one will we prefer? Behavioral style. Had I taken full adder, full adder is what? Combination. Which one should I prefer? Data flow style. So we'll prefer data flow style of coding. Let's say multiplexer. Which one will I prefer? Data flow style. So it means what? For this 1 week, when we study when we study combinational logic, we will be doing what? Data flow style of coding as much as possible, because data flow style of coding is naturally easy to follow with assign statements. Data flow, combinational logic is easy to implement using data flow style of coding. Sequential logic is easy to implement with behavioral style. Okay. Both are same. So gate level modeling is one part of the structural style. It's like a subset. So now what we will do is, I told you one thing before the break, that mod 6 counter is a complex example. Most of you, almost 50% of you wouldn't have followed everything. Okay, no problem. But you could still correlate, right? What I was doing, I wrote two table, K-maps, till Boolean expression, you would have all followed. Then what did I do? I implemented Boolean expression using Verilog code. Whatever Boolean expression I got, that AND relation, OR relation, I implemented using the assign statement. Then I have used the D flip-flops because we require D flip-flops. And then we implemented the code. Now what we will do is, we will be implementing basic combination logic. Just give me a one. Okay, so as I said, for next 1 week, we'll be focusing on combinational logic implementation. So we will start with the simple examples like multiplexer, half adder, full adder, subtractor, decoder, encoder, what else? Comparator, demux, what else? I'm missing. Priority encoder,
Multiplier.
multiplier. Someone is telling multiplier. Okay, these kind of circuits is what we are going to focus on. Okay, so if you didn't follow counter 100%, no, don't worry, because we are again going to do it when we go to sequential logic. Again going to do it. Why we did counter example is to tell you the difference between what is meant by low level, what is meant by high level, why we should always prefer high level because it is very close to how we think. If you think of some behavior, let's say, how will you think of a mod 6 counter? That style of implementation is called as behavioral style, also called as algorithmic style. You are implementing the algorithm, so it's also called as what? Algorithmic style of implementation. So it is always preferred compared to low level distribution. But when you go to combinational logic, we will prefer data flow level. So we will discuss what is meant by data flow level now. Okay, we will start with an example of a multiplexer. So you are all familiar with multiplexer, right? So I don't have to explain you what is multiplexer. So we will do 2x1 multiplexer, 4x1 multiplexer, and even 8x1 multiplexer, or some other 3x1 also we can try. I mean, what if there are only 3 inputs? These also we can try. Okay. So with the assumption that you are all familiar with what is multiplexer, so now let's implement mux 2x1 dot p. Let me close all other. What I will do is, we will take example of multiplexer. We will implement it using all the 3 styles. What are the 3 styles? Behavioral, data flow level, and gate level, structural level. And switch level we won't do because switch level is out, nobody uses, and that's out of question. We will see which one is easy. I will ask you, rather than me telling you, I'll ask you which one is easy. So with that we will proceed with. So mux module, mux 2x1. 2x1, 2 input, 1 output. How many inputs will be there? Will there be clock? Clock, will it be input? No, right? Reset? No, right? Because it's a combinational logic. There won't be clock, there won't be any reset. What will be the inputs to the multiplexer? I0, I1, and selection. And what will be the output? Let's say you got as Y. In module. In module. Input I0, I1, and selection. Output. Till this point, is it clear to everyone? Those attending online, can you follow? Now I'm going to do behavioral style. Now I'm going to implement it using what? Behavioral style. Behavioral means what I have to use? I told you, right? Whenever you mean behavioral means you have to use always. At the rate, what should I write? There is no clock. Always at the rate I0 or I1 or selection. Means what are you telling basically here is whenever I0 changes or I1 changes or selection changes, you come into this always block. This is called as sensitivity list. I0 sensitivity list. In simple analogy, sensitivity list means what? For your teeth, let's say as you grow old, sensitivity increases. Means if you drink very hot thing or very cold thing, you feel sensitivity. Same way, I mean, then you go to the doctor. So it's like telling whenever either I0 changes. Changes means what? Goes from 0 to 1, 1 to 0. Any change happens. Whenever I1 changes from 0 to 1 or 1 to 0, or again selection goes from 0 to 1 or 1 to 0, we will enter into this always block. When you enter into always block, what will you do? You will check selection value. If selection equal to 1, what will be the value of Y? I1. Else, I think I should write in a different manner. Else selection equal to 0, then I 0, else y will be x. See, if selection is 1, y equal to I1. If selection equal to 0, I not. What if selection is neither 1 nor 0? That's also possible, right? Selection can be unknown value, right? Do you agree with that? In VLSI, there is a concept called as unknown value. It can be unknown, neither 1 nor 2, or it can be floating. In all those cases, which line number it will come? Line number 9. What if selection value is unknown? We'll come to 9th case. Selection is 1, which line will go to? 7. What will be the value of y? I1. What if selection is 0? Line number 8. You got it right. So this is how we implement a multiplexer using behavioral style of coding. This is called as what? Behavioral style of coding, where you are writing the behavior. Writing the behavior, always things changes. Then you value of selection. Then y will be I1, else y will be I0, or y will be unknown. Because selection is unknown, y is also unknown, right? For this, we develop something called as Testbench. What are we developing? A Testbench. Why Testbench is required is, I develop this code. This is how you write the logic. You remember basic radix system in Verilog in digital design, you would have covered, right? What does it indicate? What is the size of this variable? One bit. What is the radix format we are using? What is x indicates? Unknown. We are indicating that we are assigning y with value whose size is 1 bit. We are assigning in a binary format, and the value we are assigning is what? X. So that is what 1 tick bx means. What does 1 tick bx indicate? Let me again repeat. 1 indicates what? Size. What is the size of output? 1 bit, right? Is it a scalar or vector? Scalar. Scalar means how many bits? 1 bit. So it is 1 bit. In what format we are assigning? Binary. Here, unknown. Rangalakshmi, is it clear to you? Okay, next. Now, let us write a test bench. Why test bench is required is, I will do some small things. Tell me, is this code correct now? No, right? This is not correct. This is not correct. Many times, you can't see, by seeing the code, you can't tell. Here it is still possible. Why? There are only 10 lines are there. How many lines are there? 10 lines. What if there are 1000 lines? Can you see 1000 lines and tell whether it is correct or not? Not possible, right? Looking at 1000 lines, I will give you some examples. I don't want to deviate, but let's quickly do something. It's not there. Anyway, let's not deviate much. I mean, it breaks the flow. What I was trying to tell you is, if I show you a Verilog code with 10,000 lines of code, it is not possible to tell where the mistake has been done. By looking at the code, you can't tell the mistake. So what is the proven way of telling is, you take the design, you apply inputs to the design. You take the design, you apply inputs to the design. The outputs will tell you whether it is working properly or not. If the output comes as you are expecting, let's say if I'm typing here 0, if 0 comes here, if I'm typing 1 comes here, then it is working fine. If I'm typing 1 and here 2 comes, then what does it mean? There is some connection mistake in the keyboard level. You agree with that? So by looking the keyboard, you can't tell that. By typing the inputs to the keyboard, you can tell that. Same way, by looking at the code, you can't tell whether the code is good or not. By applying inputs to the code and you get the output, there you can tell whether it's working properly or not. So this is where we have this. Selection is 1, y equal to I0. Right now, we do something called as test bench development. What do we do as part of test bench development is, This is what we do. We instantiate the multiplexer. We instantiate the multiplexer. We generate and apply inputs. We apply some inputs to the design. What inputs? I0 equal to something, I1 equal to something, selection equal to something. What we will get as output? Y. We check the value of Y. Is it coming as per my expectation or not? If it is coming as per the multiplexer behavior, then is the design working fine? Yes. If the output comes wrong, then design is wrong. This is how we do. Let us see how this test bench will be logged out. First thing we do is to check the multiplexer. We need to include the multiplexer. Have you done any basic C programming? In that you see they include hash include. Here we do something called as tick include. Multiplexer 2x1.v. Because we want to use the multiplexer, we need to include that code. Then what do? Module TB and module. We're developing a test bench. See, instead of writing test bench, a long statement, which is better? Writing TB is better. Module TB and module is better. Inside this, what do we have to do? We have to declare these ports. Remember that whatever design inputs, outputs are there, you just copy the same line, convert input to register, convert output to. This is a basic guideline. As of now, just remember that whatever design is there, from there you get the input and output ports. You keep it here. Inputs are converted to what? Reg. Convert input to reg. Convert output to wire. Convert input to reg and output to wire. Then you take the design. You have to instantiate it. What is this mean by this is? What is mean by this? This is called as design instantiation. It is like if I want to verify a design, this table, you see the table on which my laptop is present, this table is like the test bench. My laptop is the design. If I want to verify the laptop, can I keep this laptop in office room and verify here? I want to verify my laptop. Can I keep it in my office room? And can I do something here and verify that? No, right? My laptop has to be kept on the table, on the test bench. That is like keeping the laptop on the test bench. Keeping the design on the test bench. It is like saying keep the design on the test bench. This is like connections, doing connections to the laptop. See, once you have kept the laptop like this, let's say this laptop, you need to do the connections, right? Without doing the connections, how can you apply inputs to the laptop? Do you agree with that? If I give some input here, that input should go into the laptop. This is those connections. And here also some connection. Then only I can use input to the laptop, I can get something from the laptop. These are those connections actually. Okay. I will explain little more complex things as we go forward. Right now, understand that we have done the connections. Now, just keeping the laptop, is it sufficient? I have a table. DUT stands for design under test. What does DUT stand for? Design under test. The design that you are testing. Now, again, coming back to the laptop example, I have a table. On the table, I have kept the laptop. Will it test automatically? What do you think I should do? I should apply inputs, right? I should generate inputs and I should apply those inputs to the laptop. Then only laptop gets tested. See, without me typing anything in the laptop, will it test automatically? No. Now we have to generate the inputs. Generate and drive inputs to design. What we have to do? Generate and drive inputs to the design. That we are going to do in one block called as initial block. What is initial is it happens one time. Whatever is there in the initial, it happens one time. What is meant by applying input? I0 equal to 1, I1 equal to 1, selection equal to something like that we apply. Okay. Will it be sufficient if I apply only one time and say that it's working fine? No, right? I have to apply multiple times. So for that, we use something called as repeat step. I'm applying the things repeatedly. Now, if I take my laptop, if I type only K every time, will it be good practice to just check K only always? No, right? I don't want to check the same input always. If you see, same thing is happening here. What is happening here? All 10 times, all the 10 times, repeat 10 means what? 10 times do something. You are applying the same input. You are applying the same. Is it correct practice? No. What we are going to do is instead of one, $random. $random. What is $random is? It is a function system. It's a Verilog built-in function. It automatically generates a random number. It automatically generates a random number. Next, if I am typing keyboard, can I apply all keys at same time? All right, I give some gap. Once I type K, to type S, I will take some gap. Again, to type next alphabet, I will take some gap. So what I will do is, I'll give a gap. This is called as one time unit delay. Means after inputs are applied, I'm giving one time unit delay before I apply the next inputs. Let me again, I have a multiplexer. If I apply all inputs at same time to the multiplexer, what will happen? The last applied input will take effect. Rather, what I will do? I will apply one input at 1 second. I'll give a gap. Next input at what? Second unit time. Next, I will again give one time unit gap. Next input will be applied at what time? Third time unit. Like that, at every time, 1 unit, second unit, third unit, I'm giving a gap of one time unit. #1 means one time unit delay. What would #2 would be? 2 time unit delay. If I write 10 means 10 time unit delay. So you may ask, why don't you use #2? Why don't you use #1? Why don't you use #10? You can use #10 also, no problem at all. I just use #1 because I wanted delay between one input and next input. That's all. My test bench is completed. Test bench is completed. What I'm going to do is, I want to check whether everything is getting printed. I mean, is the multiplexer behaving properly or not? I do something called as display. Do you remember what is printf in C programming? What does printf does? It prints the value. Same thing $display does. Whatever is printf in C program, it is $display in Verilog. No difference, absolutely no difference. %d is used for printing time. %d is used for what? Decimal. %b is used for binary. So same concept. %t is used for printing the time. What time currently the simulation is at? I0 equal to %b, because I want to print the binary value. I1 equal to %b. Selection equal to %b. Y equal to %b. Here you go and type $time. I0, I1, selection, and Y. Let me explain this order. What is this order? How many percentages are there inside the double quotes? 5. Those many variables should be there on the right hand side. As many percentages, those many variables. What does $time corresponds to? $time gives you the current simulation time. What does I0 corresponds to? I1 corresponds to? Selection corresponds to? Y corresponds to. So what is that it does is, it will print instead of this dollar time value will be printed. Instead of percentage B, what value will be printed? I0 value will be printed. Instead of this percentage B, I1 value will be printed. Now, will it be correct if I reorder this? If I, let's say, I write I1 here, will it be correct? No, right? That order need to be followed, right? What will happen? Here I will be printing I1 value. Here I will be printing I0 value. Will it be correct? No, right? Hence, that order need to be followed. So this completes my test bench of multiplexer. What are we do? What did we do in my test bench is understand in a very simple terms. Let's go back to laptop example. I wanted to check what? Do I want to check that my bench or do I want to check my laptop? Right. So what is the first thing I will do in my laptop? I will carry the laptop. I'll put my laptop onto the table. That is like this. That is like keeping the laptop on the on the bench. This is like, what is it like? Doing the connections. If I just keep the laptop, nothing will happen, right? I need to do some connections into the laptop. That is like connections. Talk more about connections sometime. Right now, just understand. You may say why you are using same name, why not different names? That also will do. What is this like? I need to apply inputs, right? Whether if I don't apply any inputs to laptop, how laptop will get checked? Nothing. Then I'm giving a delay. Why I'm displaying? I want to see the values, whether Y is getting generated properly or not. That's why I'm doing display. Now, please tell me if you didn't understood any of these things. If you did not follow any of these things, please let me know.
Yes, sir. Random will check all this combination. I mean, in this all 10 o'clock, we will check all the combination. Is there any guarantee, or we may do some extra?
So what? See, if I take I0, I1 selection, how many scalars are they? Scalars or vectors? I0, I1, I selection. They're scalars, right? They're scalars because 1-bit variables. There are 1-bit scalars. So tell me how many unique combinations are possible for I0, I1 and selection? 8.
9.
8 combinations.
Actually, 8. Yeah, 8. Yes.
Not 9. 8.
8. Yeah.
3 bits are there. 8 combinations are possible. I'm generating how many times? Repeat 10. 10 times. So assumption is that most of those combinations will get covered. If I generate 3-bit variable 10 times, most probably most of the combinations will get generated. Is it clear to you?
Yes, sir. But all combinations
What
cannot
I'll
be
do is,
generated also. That is also possible.
no need to generate all combinations. I'm telling what, if I have to check my keyboard, I don't have to type each every. If I can check 80% of the keys and it's working fine, then it's kind of fine.
Okay, fine. Right, right. Okay.
You don't have to type each every key. There is one more way of running the simulation. It's called as EDA Playground, edaplayground.com, where simulators are available on the website itself. You can run the simulations on the website itself. We'll try that. Before that, you need to log in. Since you are going to use model sim, they probably are not going to provide EDA Playground, but you can even ask them. Okay. See, design.sv means what? Design code. What is design for me? Multiplexer, right? Multiplexer 2x1 is the design. Testbench.sv means what? Testbench code. What is the testbench? TB mux 2x1. So I'm going to go to this code. I'm copying this code. Paste it here. I don't have to do this include. This include is not required because it gets included automatically. The design file automatically is included, so I don't have to do that. That is how this EDA playground works. EDA playground works in such a way that whatever is there in the design.sv automatically gets included into Testbench also. When you run with EDA playground, there's one step you have to do additionally. That is something you will learn with practice. Initial, begin, end. Dollar dump vars dollar dump while 1.vcd, something like that you have to do. You have to dump the variables. Dump means create a database of variable values, and into which file we have to do 1.vcd. It can be anything. It can be mux.vcd, any name for that matter. VCD means value change dump file. Whatever values changes, I0, I1 values changes, it will capture those values. Let's go to tools. Select the tool, any tool. Let's say model sim tool, mentor tool. Open EP wave. Means open the waveform after the simulation is run. Now you save it. There is so I don't know why it's again asking me to log in. Wait. I'm logged in. I choose one of the letters. I open EP wave. Now save it. Let me do one thing in that case. I like to putty. Actually, it's all because my laptop is not there. Otherwise, in my laptop itself, tool is there. Just restart it. Okay. Kernel. I have copied the design and I have copied the test bench. Whatever we did for counter, remember that mod 6 counter, I'm going to follow the same steps. So first thing is I have to invoke the tool. If you ask me, do I have to do all this process in your system? No need, because in your system, lab tool will be directly installed. You can directly invoke the tool and run it. Okay. So when we go to system Verilog, this process is required. When you go to system Verilog, you'll have to do it on server. That time you follow this process. It is also not going to be complex. You see, I logged in, I opened the terminal, I'm doing everything. The tool is invoked. First thing we do is what called as compilation. We have to compile the code. TB mux 2x1. There's a problem, illegal reference to net-y. When some mistake I have done in the code, that mistake is right. So the point here is whenever you use any variable on the left hand side inside always block, understand, inside the always block, if there is any variable on the left hand side, it must be a reg variable. Tell me which variable is on the left hand side here. Y. Which variable is on the left hand side of the statement? Y. Here Y. So hence Y is a reg variable. Now if I run this code again, compilation is clean, 0 errors, 0 warnings. Then we do something called as vsim now what I did is called as elaboration. This command is called as vsim is called as elaboration. What is meant by elaboration is the tool has done the compilation of the different components. It connects everything. Means TB is the top, below that multiplexer is there. It understands that structure. That is called as elaboration. Or I will tell you in simple example. Let's take the laptop example. See, now laptop is kept on my table. Someone comes from outside. He will see this setup. He will see how this is arranged. He will visualize, right? How he will visualize? There's a table whose height is how much? Let's say 1 meter. On this table, laptop is present, which all connections are done. He will visualize that and he will think of that in his mind. That is called as elaboration. The way I will build the structure of the whole environment is called as elaboration. Then once you are done with elaboration, you add the information to the waveform. Add wave. Once you have done the wave, you do run simulation. I'm running the simulation. Can you see the values here? Tell me, is it behaving like a multiplexer? Please tell me. What is the value of selection? 1. What should be the value of y? I1, right? What is I1 value? 1. So what is y? 1, right? Is it behaving like a multiplexer? Selection is what? 1. So what value should be taken? I1. Is it taking I1? No, right? Is it correct? No, right? Something somewhere is wrong. Do you agree with that? Again, let's take one more thing. Is it behaving like a multiplexer? No, right? What is wrong?
Sir, in the code, it's written
Can you see, is there any mistake?
if select is 1, y is equal. No, if select is 1, y is equal to I naught is written.
This is the reason why we use Testbench. Understood why we use Testbench? To catch the kind of issues. Were we able to catch the issue? Were we able to catch the issue in the design? So then we will go and figure out that here I have done a mistake. Here I have done a mistake. We figured out because I ran the simulation, I applied inputs, then I saw that my output is not coming properly. Now if I run again, see, I have run various steps. If I type history, it will show me the history of commands. What I do is just copy everything. How do I select? Using mux, I ran and I selected. Once you have done the selection, go to edit, copy. I have copied. Once you have done the copy, go here, create one file. Do you know split command in Gvim? Run.do. I, Alt E, press. It got pasted. Now I don't need this. Do you know visual block? No, right? I'll explain later. I mean, we are selecting a block, deleting it. That is called as visual block. Now the advantage of this is, advantage of run.do is, I don't have to do step by step. Just do run. It will do all the steps for me. Whatever steps you have kept in run.do, it will do all of them one by one. If you just say do run.do. Right? VMRC, yeah. It will do all the things. Now if I see this waveform, can you see the behavior? Let's say if I keep my cursor here. What is the value of I naught? 1. I1 is 1. Selection is 1. What should be the value of y? I1, 1, right? Let's say if I keep my cursor here. Tell me what is the value of I naught? 1. What is the value of I1? 0. What is the value of selection? 1. So which one should be selected? I or I1? I1. What is the value of I1? 0. What should be the y value? 0. Is it working fine? Is this behaving like a multiplexer? Somewhere here I keep my cursor. Tell me here. You see here. What is selection value? 0. Which one should be selected? I naught should be selected, right? I naught. What is I naught? 1. What is the value of y? 1. Is it behaving like a multiplexer? Now, did you understood how we used a test bench to find the issue? See, earlier there was an issue some time back. We fixed the issue. Now is it working fine? So that is where you have a design. To verify the design, you need a test bench. So what are the two things you do in a test bench? That also. We will do that also. Here we can't see that. We need a different tool for that. Clear, right, till this point. Now what we will do is, this multiplexer, what I have developed, is it developed in which style? Behavioral style. What we will do is, we will implement it using Dataflow style. We'll implement it using Dataflow style. Because I am implementing Dataflow, I am giving underscore Dataflow to tell that implementation is Dataflow style. If I show you this code, will this line change? All right, it will be same, right? It won't change. Will this line change? No. Will this line change? No. Input output will be same, only reg won't be required. Going forward, you'll realize that reg won't be required. Will the code be required? Line number 5 to 10. We are doing in Dataflow. Will it be required? All right. So remove, assign. So what is the statement? What is the keyword used for Dataflow? Assign. What is that we want to assign to? Y. Y is what is our output is, right? Y equal to selection equal to question mark I1. That's all. In fact, this is also not required. Done. Our multiplexer is implemented. 2x1 multiplexer code is implemented. What are we telling here is check the value of selection. If it is true, Y will take I1 value. If selection is false, 0, Y will take. If selection is unknown, Y will take unknown value. What you are telling is, if selection is true, true means what? 1, Y will be I1. If selection is false, false means what? 0, Y will be I0. Hence, Y will be unknown. One statement indicates these three meanings. Simple, right? What we are telling is selection you are questioning. You are putting a question mark to the selection. Are you true or are you false? If you are true, I will give I1 to Y. If you are false, I'll give to I0. This style of coding is called as data flow style, where you are checking the data and based on that I1 is flowing to Y or I0 is flowing to Y. Now, if I show you both the codes, tell me which one is easy. Data flow is easy or behavioral is easy? Data flow, right? So for combinational, which one is easy? Data flow. That's the reason we prefer data flow. Now we will run the same simulation with what? Data flow. Nothing else. Will Testbench change? No, right? See, my bench will remain same. My bench will remain same. Only thing is what? To check a new laptop, I have to remove the existing laptop and then put a new laptop, right? Do you agree with that? My test bench setup will remain same, right? I don't have to purchase a new test bench and bring it. I can use the same bench. Only thing I have to do is what? Replace this bench with a different bench. So what I'm going to do, I'm going to go to this bench. In fact, this is also same. Only thing is comment it out. I'm keeping a new bench instead of the old instead of old laptop. I'm replacing it with a new laptop. That's all. Now if I run it, tell me, do I have to run individually or what should I do? Do run.do. Just do what? Do space run.do. Now check it. Is it behaving like a multiplexer? Can you check? Should you look here or should you look here? Here I should see. I should see the values. See, as soon as you keep the cursor, whatever are the values, they'll show up here. What is the value of selection? 0. What should be taken? I0 or I1? I0. What is the value of I0? 0. What is the value of Y? 0. Is it behaving like a multiplexer? Yes. Let's say if I keep my cursor here, what are all the values? Selection is what? 1. What should be selected? I1. What is I1? 1. So Y is what? Are you all able to follow? Is that clear, right? This is called as, the one which we coded now is called as what? Data flow style of coding. This is called as data flow style of coding. What is the one style that is still remaining? Behavior is done, data flow is still done, structure is pending. So let us implement the structural style of coding. Mux 2x1 structural. So I will go here. I'll copy the same code. Structural means using the gates. Just say mux 2x1 using. Go to images. You know, right? I don't have to explain. You know how many will be required if I have to implement it using AND gates and NOT gates. And or and NOT gates. How many gates will be required? I will require basically 4 gates, 1 NOT gate, 2 AND gates, and 1 OR gate. See, what is the expression of multiplexer? What is the expression of Y? Yeah, yes, selection and I1 or selection bar.
I know.
Do you agree with this? Now, if I have to implement using gates, first you write NOT gate, gate 0, selection inversion. Otherwise, NOT gate is also not required. You can directly write AND gate G1, N1, selection comma I1. Second AND gate, N2 is the output of second AND gate. Selection bar I0. Then OR gate, output is what? Y, N1 comma N2. If someone is not able to follow, please let me know. Basically, what I have done is one NOT gate. NOT gate is for what? Selection. One AND gate, and finally one OR gate. So what do I do here? Output of AND gate is N1. So this I am naming as what? N1. This I am naming as what? N2. N1 and N2 becomes input to OR gate. N1 and N2 become input to OR gate. Always this value is the output. Everything else becomes input. So for this, what is the output variable? Output of this gate? Inputs. Selection comma I1. Did you understand? For the second gate, N2 is the output. Selection bar is the input. I0 is the input. For this, what is the inputs? N1, N2 is the inputs. What is the output? Now what we will do is we can give anything x1. You need to give name, right? Even if you don't give, no problem. The tool still works. But it's a good practice to give a name. The name of the gate is G1, G2, G3. So if I'm using this gate, I'm giving a name to this gate. G1, G2, G3. Giving a name. Those names are G1, G2, G3. Now, if you ask me, no, I will give P1, P2, P3. Use P1, P2, P3. No problem. It is not necessary. It's not necessary. You can write without names also. I will show you the benefit of names. Now, when I run this, you will see the benefit. Now I have third laptop. Till now, how many laptops someone gave me? 2 laptops. What is the first laptop? Laptop with behavioral style. What is second laptop? Laptop Dataflow. Both I kept in my test bench and proved that both of them are good. Now what is the third laptop they have given me? Laptop with structural. So now they are asking me to check that structural modeling laptop is also good. So what do I do with that? I comment out the earlier ones. I remove the earlier ones. Comment means what? Double slash is the commenting. I go here. Structure. I go here. run. If you remember, if you can recall, it's same waveform as what you have been seeing. The overall shape and everything, overall the waveform is exactly same as what we have seen earlier. Even if you keep anywhere my cursor, is it behaving like multiplexer? Expand it by dragging. Remove N1, N2 because these are internal gates, right? Internally we had N1, N2, right? Remove them. Now is it behaving like a multiplexer? What is selection? 1. So what will be selected? I0, I1, which is 0. So Y is what? Is it behaving like a multiplexer at this line? Clear, right? What is selection? 0. It should select I0 or I1. I0. What is the value of I0? 1. What is the value of Y? So is it behaving properly? Clear, right? So this is the third style. So did I prove that the structural style of modeling is fine? But if you see overall, if I show you all the possibilities, which one was easy? Data flow was easiest, right? Why? Because structural requires us to write 3-4 lines. Whereas data flow all could be done in just 1 line. All could be done in just 1 line. Now, what is the last style that is pending? Switch. So in switch level, what do? Is we convert everything into transistor level. Then you write NMOS, PMOS, all that, which let's not do because you will never do that and it's not required also. That is basically not required for us. Now what we will do is, with the same understanding, let's try to implement a 4x1 multiplexer. With the same understanding, we'll try to implement 4x1 multiplexer. Since we have already done 2x1 multiplexer, 4x1 multiplexer will be very easy to do. Okay. So before I go ahead, those attending in classroom, do you have any questions? Okay, what about those attending online? Any questions you have? Okay. Someone is asking, inside AND gate, please read this once, everyone. Do you understand this question? What is this question is referring to? When I'm writing the gates, why we are keeping the output first? That is the rule. When you use logic gates, any logic gate, AND gate, OR gate, XOR gate, anything, output first, inputs later. But when you develop something, you can develop in any order. See, I can, instead of this, I could have given Y here first. When I develop, I don't have any restrictions. But when you use something that is present in the design, always output first, then the input variables. That's a rule. That's a rule. You are getting the point. You cannot write N1 here. It will be wrong. No, in behavioral, is there any AND gate? Nothing, right? Only in gates there are gates are involved. Is that all clear to everyone? Next, what do we do? No, model sim and Questa sim are exactly same. Exactly same. Model sim and Questa sim, both tools are from Mentor Graphics company. Both are from Mentor Graphics. instead of Questa, if you write model sim, tool will look the same. Same, exactly same. Only thing is model sim tool doesn't support system Verilog advanced features. Questa sim supports everything. Otherwise, both of them are same. If you ask me how do they look, if I show you another mobile phone like this only, they will look same. Only thing is this the one which is advanced mobile phone has little more internal features, applications which other mobile don't have. Otherwise, look wise, usage wise, both are exactly same. Clear, right? Next. Any questions, those attending online? Okay. Now we will move on to implementing a 4x1 multiplexer. We will do it quickly. Why? What is that I am trying to tell here is, once you do one simple design all by yourself, second design is very, very straightforward. How much straightforward you see now? Okay. So mux 4x1 behave.v. What is that I am trying to develop? Behavioral style. So I will copy mux 2x1. What should be changed? 4x1. How many inputs will be there? I2, I3. Here what I have to do? What about selection? Will it be 1-bit variable or how many bit variable? 2-bit. So will it be scalar or vector? Since it's a vector, I have to declare in a different line. Did you understand? Since it's a vector, so it has to be declared in a separate line. So that's what I've done. What is the size of selection? 2-bit. So 1 down to 0. 1 colon 0 means what? A 2-bit variable. If it is 4-bit variable, what I would have declared? 3 colon 0. 3 colon 0. What about y? Will it be scalar or vector? Scalar, right? See, even for 4x1 multiplexer, output will be 1 bit only, right? So tell me, is it scalar or vector? Scalar. Now, what do I have to do here? What do I have to do here? Selection equal to 2 tick b 1 1. If both are 1 1 means selection is 3. What should be the y value? I3. Got it? If selection is 2 tick b 1 0 means what is 1 0 in decimal? 2. What should be selected? I2. What if selection is 0 1? 1. What if selection is 0 0? That's all. Our coding is done. Our 4x1 multiplexer coding is complete. What is that you really require in this coding is GVim skill section. Little more GVim. I mean, how to copy a line, how to paste it line, how to edit, how to replace a word. See, earlier it was I1. I was able to replace it with 0. That kind of skill set you need to develop. That along with the proper Verilog style. I mean, you need to understand how Verilog code should look like, right? That will make it very quick for you. Now, since we have developed design, what is the next thing I have to develop? Testbench. Testbench also let's develop quickly. It won't take much effort for us. I hope I created a new file. I go to this file. I copy everything from here. I kept here. Remove this. Remove this. This will be called as what? 4x1. This will be called as behave. Do you remember what is the name of the file? Mux 4x1 behave. So mux 4x1 behave. These two names are matching, and they must match. If they don't match, what will happen? You are trying to include some other file which is not existing. If I write by mistake, will it be correct? Because this file name is behave, here name is different. So I have to match the name. Then will it be same? No, right? See, rather what I will do is instead of editing here, I'll remove these two lines. I'll remove this line. I'll copy these lines, paste it here. Input should be changed to what? Reg. Okay. Output should be changed to. Now let's address some questions. Why reg is used in the main file? Why reg is used in the main file. Means what? In this case, why are we using reg here? For now, remember that inside always block. All statements, any statement, left hand side variable must be a reg. What is the statement? Any line that ends with semicolon. Anything ending with semicolon. Anything that is ending with semicolon is called as statement. In this case, tell me in this code how many statements are there? 5, right? One statement on line number 9, one statement on line number 10, one statement on 11, 12, 13. So totally how many statements are there? 5. Because 5 semicolons are there, 5 statements are there. What variable is on the left hand side? Y. In all the statements, which variable is on the left hand side? Y. So Y should be declared as a reg. Now the question comes, why should it be a reg? Because till the time next change happens, till the time I0, I1, I1, I2, I3 selection changes, we have to hold the value of Y. We have to hold the value of Y because you don't know when next time this will change, right? Till the time Y need to be hold, right? We need to hold the value of Y. Let's say Y is 1. If you see here, if you see the waveform, here what is the value of Y? 1. Till next change, here next change is happening. For this duration, value of Y should be held. You should hold. Since you are holding the value, it should be a register. Who can hold the value? Register, right? Hence should be register. We are holding the value. See, what is meant by holding? Keeping it to 1. So hence it should be a reg. So for now you understand that any variable on the left hand side, any variable on the left hand side, like Y is on the left hand side, it can be declared as a reg. It must be declared. One more concept I want to tell you here is that instead of writing such a long statement, just write star. That is sufficient. It will automatically count them as every variable. Star means what? Everything. What is everything here? Anything that is on the right hand side. Any variables on the right hand side will be considered. What all variables are on the right hand side are decision making statements, selection, I0, I1, I2, I3. All those variables will be, see, writing star here is exactly same as writing this time. So tell me, which one should I prefer? Should I prefer writing star or should I write I0 or I1 or I2 or I3 or selection? Which one? Star. So whenever you use combinational logic, whenever you write, always block for a combinational logic, always write star. The tool is smart enough to figure out. The tool, my model tool is smart enough to figure out that star means what? Either I0 or I1 or I2 or I3 or selection. You understood, right? Forget this code. If I ask you what are all the multiplexer output is dependent on? It is dependent on I0, I1, I2, I3 and selection. Like you can visualize, you can tell me. Tool also is smart enough to make that decision. Tool is also smart enough to make the decision. It will make a decision thinking that okay, star means what? User wants to include I0, I1, I2, I3 and selection. For ease of coding, should I go with line number 8 or line number 9? 9. The same exactly same thing I could have done for 2 cross multiplication. Now, is that clear? Okay. Why we are writing to tick VXX? Why are you using tick? Can you read this question, everyone? It's a radix format. If you use, it's a radix format. I'm going from here to my native place. Distance is 120 kilometers. If you ask me kilometer 120, is it, do we write like that? Why don't we write like that? It's not a standard, it's not a convention, it's not a distance convention. What is distance convention? A number followed by unit. Same way, whenever you write any radix format, you have to write 2TB. That's a rule. Is that clear? I think it must have been covered in the digital design, right? Any other questions? Now we are done with the Verilog coding. What is the next thing we have to code? Testbench, right? This is all fine. This should be changed to what? 4+1. I2. Yes. Which one? Selection. Which one? Here, what I have to do? Tell me additionally. Copy this line, change it to I2. Copy this line, change it to I3. Instead of this, instead of writing, how many lines did I write? $random? 5 lines. Instead of that lines, there is an easy way of doing called as I0, I1, I2, I3 selection. Yes. What I've done is, this operation is called as, have you done in C programming? Are you familiar with that thing? What is that called as? What is it called as? Flower brackets is called concatenation. String concatenation. Here also it is called as concatenation. What is meant by concatenation? I'll tell you. Let's say this is one variable, this one variable, just putting together all of them, making a 6-bit variable. And to that whole thing, I'm assigning a $random. What is $random is? $random generates a 32-bit variable, 32-bit random value. $random generates a 32-bit random value. Let us say in our example, let's say in our example, it has generated let's say the random value generated is what? 32 tick B 10101100. How many bits are there totally on the right hand side? We count 32 bits will be there. What is going to happen is, understand carefully now. It starts from the left, right hand side. What is the size of selection? How many bits is selection? 2 bits. Selection will get lower 2 bits. Selection will get lower 2 bits. I3 will get what now? Next, I2 will get what? I1 will get what? Next. I'm changing colors only for convenience. Though don't try to understand why red, why blue, why green. Okay. So I0 will get what? Can you count how many bits did I select on the right hand side? What is the sign of left hand side? No, selection is what? Selection is 2 bits, right? Totally, what is the size of those bits? So for 6 bits, you are getting 6 bits. How many bits are remaining here? In that case, 26. Those 26 we won't use it. Those 26 bits will be not used. They will be removed. Only lower 6 bits will be taken and will be given to the I0, I1, I2, I3 and selection. Next time when I run the same code, my random value will be different. When I run the same code next time, when I run the next iteration, see, I'm doing $random. When I run $random, what will happen in the next randomization? It will generate a different pattern. Then what will happen? See, next iteration. Next iteration means what? Next time when you come, what will happen? It will generate a different random value, something like 1, 1, 1, 1, 0, 0, 1, 1, something like this. You can't predict that because since it is random, it will generate a random value. If you ask me, will it really generate this? Will it really generate? No, you can't tell. That is the fun of $random. Because it is going to generate a random value, you will get interesting scenarios. Now tell me what will be the value of selection? 1, 1. What is the selection value of I0? 0. I0. I0 is on the leftmost. 1. What is the value of I2? 0. What is the value of I3? 0. Simple, right? No confusion, right? No confusion at all. See, instead of writing 5 lines, I will put the same thing in 1 line. See, no point writing 5 lines, right? I will achieve the same behavior by writing 1 line. See, if I had written like this, as just only 1 line like this. So instead of all this, if I had just done selection equal to $random, tell me what would have been the value of selection in this case? Only 1, 1. How many bits would have got wasted? 30 bits would have got wasted. See, out of 32, 30 bits, 2 bits you will utilize. Right hand side is 32. You are taking the how many bits? Lowest 2 bits you are taking. How many bits will be wasted? 30 bits. It's like, I'll give a simple analogy again. You have a big bucket with water. Okay. And you have 6 mugs. I'm not able to draw. You put the water into the mugs. You just throw. What will happen? Mugs will get filled. How many mugs are getting filled? 6 mugs are getting filled. Whatever is the remaining water, everything is getting overflowed and it's getting wasted. That's all. If I keep 2 more mugs, they will also get filled. How many mugs water will get wasted? 24 mugs. So like that, up to a bucket is capable of how many mugs? 32 mugs. Till 32 variables you can keep on the left hand side. If you only want to fill 2 mugs, you still generate 32 mugs. Bucket, you still use a bucket, you fill it, remaining water gets wasted. Here also what is happening is selection only can hold how many values? 2 bits. Lowest 2 bits will be used. Uppermost bits are getting wasted. That's okay, we can't do anything about it. Clear, right? Now tell me which one was easy, writing 1 line is easy or writing 5 lines is better? 1 line is much easier, right? Writing 1 line is much easier. So someone is asking, explain line number 100. In this case, what is happening is earlier in $random, I generated this random value. Now I am generating a different random value because random itself means that a random value. So what value will be taken for selection? Lowest 2 bits. What are the lowest 2 bits? For I3, what value will be taken? The next bit, right? I3 will be what? 0 will be taken. What about I2? What about I1? Sorry, this one. I0? Now, whatever bits you wanted to do, you have used them. What will happen to the remaining bits? They will be wasted. Like I told you, once you have taken the bucket and you fill the mugs, whatever is the additional water in the bucket will be wasted, gone, right? Same thing is happening here. Now you don't really have to worry because water is not getting wasted here. It's just the bits which are not being used. So you don't have to really worry about it. Is that clear to you? Right? Okay, someone had a question, so let me see. Is that clear? The person who asked the question. Okay. Vinuta, is it clear to you? Okay. So where do we start from? Do we start from MSB or do we start from LSB? LSB. Here, do we start from left hand side or right hand side? Right hand side. Always you start from right hand side. The lowest bit goes to whom? Rightmost variable, lowest variable. The next bits will go to next variable, so on. You remember that concept? Always you start from the right hand side in both the cases. You start from right hand side and you keep assigning. Whatever additional bits are there, they are getting wasted. With this understanding, let us run the simulation. Now, is this line correct?
Can we change the input bits order?
Can do anything. See, can we change the order of mugs? I have kept 6 mugs. Can I reorder the mugs? I can same thing here. Means I can keep selection here. No problem. Because anyway you are generating a random value. There is nothing like particular one will become here. It's a random thing, so you don't have any control on that. This also. Last bit will go to I3, then next bit will go to I2, next bit will go to I1, next bit will go to I0. Then the 2 bits will go to selection. You got it? You understood, right? Don't always think that last 2 bits are always selection. You have to see the order. Okay. Now, here to print it, what I have to do? I2 equal to %B, I3 equal to %B. Now, is this correct? Is this order correct? I2, I3. Is this correct? Tell me what is wrong. I2, I3 should be written after I1. Otherwise, it will be wrong. Printing will be wrong, right? Completely. The order will go wrong. Why the order will go wrong? I3 will be printed for Y. I2 will be printed for selection. Y will be printed for I3. Selection will be printed for I2. Is that correct? All right. So what do I have to do to fix this?
Change the order.
Clear, right? Clear? So now all I have to do is go to the run.do. Go to the run.do. Change it to focus one. Done. My run.do file is also updated because everything else is same. The topmost module name is TB. Everything else is same. Go here. And no, Viral we have already included. We have inclusion is already done. Testbench name is not behavioral. Testbench name is common. What you are including in the testbench is differing. Either behavioral you are including or structural or data flow. So now, just expand this. Drag it. Keep it here. Drag the mouse. If I keep my cursor here, tell me. What is the value of selection? 2db0, right? Selection is what? 2db0. 2db0. What should be selected? I0 should be selected or I1 or I2, I3? Which one should be selected? I0. What is the value of I0? 1. What is Y value? 1, right? Is that clear? Is it not visible clearly? See, this is I0, I1, I2, I3, selection Y. 1, 1, 0, 1. Right? Let's keep my cursor somewhere else. Now tell me, what is the value of selection? 2, right? You can see clearly 2 value can see. Which one should be selected? I2 should be selected. What is I2? 0. What is Y value? So is it behaving like a 4x1 multiplexer? Let me keep my cursor here. What is the value of selection? 0, right? Selection is 0. Clearly you can see 0. Selection is 0. What should be selected? I0 should be selected. What is I0? 0. I0 is 0, right? The topmost. What is Y value? 0. Is it behaving properly? Now the same behavior. You take any row. Tell me, what is the value of selection here? 1, 0. 1, 0 means what? 2. What is I2? What is y? Select this one. So whatever we did now, whatever you are doing now, you should do while sitting at home also. Whatever actively you are talking, you should also talk. People will think he's mad. He's talking to himself, but you should still do that. You know, right? You'll be sitting in PG, you'll be telling I1 is this, I2 is this, selection is this, Y will be this. You should tell that, you should talk to yourself and you should understand yourself. You're getting what I'm trying to tell? Just by seeing the video or just by seeing the code, do not think that it is working. What you should do, you should develop the code, you should run the simulation, you should see the waveform, you should see the display, and you should analyze it. Okay, I'm selecting this. Is it behaving like a multiplexer? What is selection value? What is selection value? Selection is 1 0. 1 0 means what? 2. What is I2? 1. So Y is 1. So it is working correctly. That's how you should tell to yourself. Because if you tell to yourself, then you will be able to tell to other person, right? So when you go to interview, you should be able to tell to other person. So you should do that practice now itself. You can't directly go and tell in the interview, right? You have to start that practice now itself. Now did you understood how multiplexer is working? So now we will go to the next type. Another 10 minutes we'll wind up. Okay. So we have done what style of coding? Behavioral style. So now what I'm going to do? Data flow. Again, what I'm going to do? I'll copy this code. Will line number 1 change? Line number 1 will be same or different?
Same.
Line number 1 same, right? Because multiplexer will have same number of inputs, same number of output. Doesn't matter whether you do in behavioral, whether you do in structural or data flow. Will line number 2 change? No, right? Same. What about line number 3? Same. What about line number 4? Same, but only reg won't be required. Because there is no always block. If there is no always block, there is no reg. If there is no always block, there won't be any reg. Now, do we require line number 6 to 15? No, right? Because we are doing what style of coding? Data flow. Data flow means what? Assign. So do we require line number 6 to 15? No. I want to remove these lines. How do I remove? What is the keyboard shortcut? How many lines is this?
3 lines.
10 lines, right? 10 dd. 10 dd. Done. Okay. Now, what is that I want to do? Assign y. I'll tell you that only. Okay. If selection is equal to 2 tick b 1 1, equal to 2 tick b 1 1, then I3 colon. Again, if selection equal to 2 tick b 1 0 question mark I2, again colon, again colon. If selection equal to 2 tick b 0 1 question mark I1, again question colon. If selection equal to 2 tick b double, I think it should be fine, or I0 is sufficient. This is one way of doing it. Simple, right? What am I doing? If selection is 2 tick b 1 1, if it is true, what variable will go? I3 will be assigned. You are questioning that. If it is that questioning is true, y will get what? I3. Else this whole expression will be evaluated. Again, you go and evaluate this expression. If it is true, I2 will be given to y. Else, again you evaluate this whole expression. If this is true, what will be given? Else will give what? Clear? Right? The same thing could be written in different way also. I'll explain that also. Okay. For now, let's run the simulation. Those attending online, did you understood? This is a complex expression. you need to you need to spend time and understand. Means it is actually complex. Okay, if I close this right now, everyone write it now. Those are writing online, please write it now. Also, everyone. There are 37 participants. I want all 37 participants online to respond with some answer. Okay. Anyway, those in classroom, I will come and check. Just think, how did I start? Assign. What should be variable? Y equal to what? How do you start? By start checking the selection, right? What is that you start selection checking? 2DB1. Then what will you use? Question mark. That questioning you should start doing. Do not develop complete code. Okay. Just I want you to write assign statement. I want you to just write assign statement. I told you right, the statement only right. Column here column is there is corrections here and check compilation. That to check selection equal to equal, right? Equal to equal, not column. Equal is the checking, right? Equal to equal, right? No column. Question mark. Question mark. Question mark. I did not see any response from the online students. Not even a single person has replied. Not even a single person has given the answer. Again, I didn't see any response from the online students. Whatever you have done, please post it. Whatever you have done, please post the answer. Those attending online, whatever you have done so far, you please post it. Is it like classroom students are smarter students here? Right, then what is happening? Nothing. No, they don't want to respond. Here you have here, right? I'll come and check it. There they don't have fear. I can't go to their house. Again, I'm asking, requesting, please post it. I want to see what you have done. I'm not going to say anything, even if you post wrong answer. When I went to classroom students, they have done mistakes. I didn't say anything. I got one response from Kishan, but that is again not correct. Why is it not correct? No. My question was different. My style of I asked you to do in different style. Please do not post private messages. Those attending online, please do not post private messages, because I have to explain to the other students what you posted on. So I will not, going forward, I will not respond to private messages. My question is, see, now someone is asking what is the question. My question is, I asked to just replicate this code. I asked you to just replicate this code. Okay. So what is that you have to take out of this session is, you have to participate in the session. First thing, you have to focus in the session. See, there are two types of studies. Please listen everyone carefully. Please listen everyone carefully. Your 1 hour has to count. What is counting means? One is sitting and thinking about something else, thinking about girlfriend, many things, right? You can do. What is the other way? 1 hour, make it count. Focus in the session. Just listen what trainer is telling. Do not write anything. Just focus what he is doing step by step. Where you are stuck, try to utilize. Otherwise, if you don't do that, what happens is you have to spend a lot of time outside the class. If you don't utilize this 1 hour, if you don't utilize this 1 hour properly, you have to spend another 2 hours to understand what I thought. So try to be focused in the session. Try to be focused. Whatever it takes, try to be focused. Whenever you lose the focus, you again bring back your thoughts to the class. Whatever you didn't follow, you ask me again. Okay. So please try to make the best utilization of whatever hours you spend in the class, so that it will be effective for you. What is my question was? I taught you this style. I asked you to write the same code. So what did I do? If selection is 2 tick B 1 1, if it is matching 2 tick B 1 1, then I said I3 will go to Y. If not, this whole expression will go to Y. But what is that whole expression? Again, you have to solve. What is that you solve? If selection equal to 2 tick B 1 0, I2 will go. Else, this whole expression need to be solved. What is that whole expression again? You have to solve this. In that case, I1 will go or I0. Okay. Again, what is important here is, many times when I'm developing code, things look easy for you. This looks easy. If I close this code, ask you to do again now also, you will find the difficulty. That difficulty is natural. It will happen. It happened with me also. It happened with you. Everyone, it will happen. There's a threshold you have to overcome. There will be something like this. You're somewhere here, or you're somewhere here. You have to reach this point. Once you reach that point, the programming becomes easy for you. You're getting this diagram. I'm teaching a little bit of chemistry. What is that I'm telling is, you need a little bit of practice to reach that point. Okay, that difficulty you have to go through. It happens with everyone. Even the best coder, maybe Bill Gates also might have seen the same difficulty initially. At one point, you might have seen the same difficulty to reach this point where he starts finding programming enjoying experience. Once you reach that point, this is where you enjoy the programming. Like if you ask me now, if you give me any example, I enjoy programming. Now you probably won't. You will be finding little difficult. So that is because you are in this phase. It will take little time for you to reach this point. Once you reach, it will be enjoyment. So that will come with little bit of practice. Okay. So you have to challenge yourself. Can I close this laptop and can I develop this code? Can I run the simulation myself? Can I analyze the waveform myself? Wherever you are stuck, please talk to the trainer, me or other people, and get your doubts clarified. If you just sit yourself, if you keep your questions to yourself, will someone know? No, right? Nobody will clarify. So you always have to talk to the trainer, get your doubts clarified. So always remember, again I am telling, no trainer will tell you what is your doubt. Can I come to you? Can I explain your doubt? Nobody will tell you, right? Right? Even if your father is a teacher, he won't tell you, right? So you have to ask your father, I have this help, you please ask me. Same thing in the classroom. Wherever you're stuck, please feel free to take the support. Okay. Next. So we are done with what? We are done with data flow. Now let's see whether data flow is working properly or not. We want to see data flow is working properly or not. What will I do? Replace it with what? Data flow. Simple. Go here. What should I do? Do run dot. You will see that it's behaving like a multiplexer. If you don't want to see the waveform, you go here, any of these lines. Let's say randomly I take line number 8, time 18. What is selection value? 0. What will be the I1 value? What value should be selected? I0. What is I0? What is Y value? It is working, right? So this is how you should be doing. I'm telling you should be learning like this, sitting like this, analyzing yourself whether it's behaving properly or not. That question that need to be done. Okay. Now what is remaining? Structural, right? Let's do structural also. With that we'll wind up. Okay. So mux 4x1 structural dot v. Again, what I will do, I'll copy the entire code from here. Let's close the other ones. In structural, tell me how many gates are required for structural? 2 NOT gates,
4 AND
4
gate,
AND gates.
1 OR gate.
Okay. To implement a 4x1 multiplexer, you need 2 NOT gates, 4 AND gates, 1 OR gates. For now, I won't use 2 NOT gates. I'll directly use the tilde. Tilde means what? Not operation. So AND gate is what? First AND gate is G1. What is the output? Let's call the output as N1. Some net 1, some output 1. What are the inputs? Selection of 0, selection of 1. When both of them are 1, I3 will be selected. When both selection 0 and selection 1 are 1, I3 will be selected. G2, N2. When this is low, this is high, I2 will be selected. Selection 1 is true, selection 0 is false, I2 will be selected. Purposefully, I am not drawing the diagram. I can draw the diagram and explain, but I want you to do yourself. Because why I should not do? You have already learned in digital design. This diagram you should be familiar. What I am explaining, it should be familiar to you. Tell me in the third case, what should I do? Selection 0 should be true. Selection 1 should be false. Then what will be selected? I1 will be selected. In the fourth case, both are false. If both are false, what should be selected? I0 should be selected. What is the final gate? OR gate. What is the output of OR gate? Y is the output. Y is the output. N1, N2.
N2, N3, N4.
Why I didn't use 2 NOT gates is because anyway I can use tilde operation. So tilde will anyway do the inversion. So this is how we implement a 4x1 multiplexer using structural modeling. Now since I have developed a structural, what should I do? Structural dot. Go here and now once this simulation is over, how do I prove that this is working? How do I see that it's structural? If you open the DUT, what do you see? G1, G2, G3, G4, G5. How many gates did we use? 5 gates, right? 4 AND gates and one OR gate. So is it behaving properly? You just select anything. Tell me, is it behaving properly? 1 0. 2, right? 1 0 means 2. I2 is selected. If I do some mistakes, except if I go here, will it work now? It won't work. You will catch that mistake also. If you run this now, you will catch mistake actually. You will see the mistake. Somewhere you will see the mistake for sure. Tell me which line is the mistake. There is some line will be mistake. Tell me one line which is mistake. You tell me the time. Time 2 is wrong, time 4 is wrong, like that you tell me. I can see one thing wrong first immediately. What is wrong? Only one mistake is there. Let me see how many people can tell. One timestamp, there is a mistake from 2 to. This is correct only. Someone is telling 20th line. This is correct only, right? 0. I0 selected. I0 is what?
14th.
Y is what?
14th line.
Someone is telling 14th line. That is also correct, right? Selection is 1 0. 1 0 means what? 2. I2 is what? 0. Y is what? 0. Then which one is wrong? Which one is wrong? Huh? Let's take this line. Wait. That is the selection is 0. Wait. I saw somewhere one mistake is there. Wait. Wait.
Everything is correct.
Oh, okay. Selection should become 1 1. Okay. Yeah, I think I mistake. I analyzed wrongly. So if selection becomes 1 1, there will be a problem. Okay. So for now, yeah, because I think we need to generate more scenarios to catch the issue. For now, you see instead of repeat 10, you do repeat 20. You will probably end up reaching one scenario where things will be going wrong. Clear, right? How we have done, right? So we will stop the session here. So what we have done today, 2x1 multiplexer, 4x1 multiplexer. In the next session, we will focus on half adder, full adder, subtractor, decoder, encoder, everything. Things will be little fast at that time, because till now we learned Testbench, how to develop design, what is behavioral, what is structural, what is data flow, everything. So since you know what is half adder, since you know what is behavioral, the coding should be faster. Tomorrow's session will be only lab. You please carry your laptop. I think in the meantime, our trainer will tell you how to install the tool. He will give you the link where you have to download the tool and install it. Tomorrow it will be lab session. Tomorrow, if possible, day after tomorrow also. Till the time you don't get comfortable till my stage, you should reach my stage. What is my stage? We have implemented 2x1 multiplexer and 4x1 multiplexer. Maybe if possible, half adder and full adder also. Till that time, there won't be any further theory session. After that, again my session will start. Okay. So I will be sharing this code with you, whatever I have done. Please do not wait till tomorrow 9:30 or 10 o'clock. You should do today itself. Should be starting now itself. You're getting what I'm trying to tell? There is a tendency that I'll go home and relax, or I'll go roam around Bangalore. I'm telling, after lunch, 3 o'clock, you sit, start what we have done the revision, and start doing the coding yourself. Lab session is not where the trainer is supposed to tell, now you start coding, now you write module. You should have done everything today itself. Tomorrow is the time to get your doubts clarified. Okay, please remember that in mind. So there are two ways of approach. One where thinking that everything will be done by the trainer, everything will be made by the institute only. That approach will not work for you. The approach that will work is what? Once you go home, you start doing yourself. Right? That is the right approach. That is what will get you the job immediately. Okay, thank you. We'll end the session.